Here we have to find the equation of the normal to the curve y equal to e to the 1 minus x squared perpendicular to the straight line y plus 2x minus 4. Let's make a quick sketch of this function. It is an easy function to draw. The maximum of the function will be at x equal to 0. It's quite easy to figure out because when we increase x or we decrease x, x squared will grow larger and this argument here will become smaller and possibly also negative. So at infinity the function will flatten out and it will go to 0. Whereas at x equal to 0 it will be equal to e. So the function will be something like this. And we want to find the normal to the curve and also to this line here. What is that line? Well, that line is something like this. At x equal to 0 it is equal to 4 and then it will have a negative slope equal to minus 2 and it will be something like this. If we want to find the normal to this line, which is also normal to the curve, we need to find the tangent to the curve. So the tangent in particular to the curve, for example, somewhere here, I mean, it is quite intuitive that there will be some point that I will call x0 such that this line will be parallel to this one. So this red line is parallel to the black one. And the normal to this line, to this red line, will also be normal to the black line. Okay, so we need to find the tangent to the curve, which is parallel to this line here. How do we find the tangent? Well, we need to find the slope at x equal to 0. The slope at x equal to 0 is equal to y prime, so the derivative of the function y calculated at x equal to at x0 or x naught if you want. The derivative of that is equal to minus 2x0 times e to the 1 minus x0 squared. It's quite easy to calculate from this one. And the curve, the black curve here, has the following equation: y equal to minus 2x plus 4. So this is the slope of the line, which should be the same as this one at x equal to 0. So if you set x0 equal to 1, x0 will be equal to 1 here, and this exponential will be equal to 1 as well at x0 equal to 1. So the slope will be minus 2, which is exactly this slope here. So x0 here is equal to 1. And the equation of the tangent is y of x equal to y prime of x0, which is minus 2, times x minus x0. So x0 is equal to 1, so it's x minus 1, plus, here we have to put y of x0, or x naught. What is y of x0? Well, you can see that from here, y of x0 is just simply 1. So let me put 1 here. So the equation is minus 2x plus 2 plus 1. So it's plus 3 here. So this is the tangent to the curve here, and this is the red line, which is parallel to this line here. And then the last step is to find the normal, because this is the equation. This is the equation of the tangent, and it is the red line, but we also need to find the normal at the point x0. So how do we find the normal at the point x0? Well, we need to find the line, another line y of x, which passes through this point, which is the point x0 equal to 1. So we have some coefficient here that I will call alpha times x minus 1, and then we have plus y of x0, and y of x0 at this point is just simply equal to 1, because this ordinate here is equal to 1, so this is also equal to 1. And the coefficient alpha is just simply the anti-reciprocal of this one, so it will be minus 1 over this coefficient here, which is minus 2. So the result is 1/2 here, and the equation of the normal will be 1/2 times x minus 1 plus 1, or if you want, x over 2 plus 1/2. This is the equation of the normal. How do you check that this is the normal to the curve, which is also perpendicular to this line, to this black line? We can find 2 points which belong to this black line here. For example, the 2 points are 0, 4 and 1, 2, which is quite easy to see that these 2 points belong to this line. And from these 2 points, if we make subtraction, we get, for example, 0 minus 1, which is minus 1, and 4 minus 2, which is 2. So this is the direction of this black line here. This is this is a vector which belongs to that line. It is parallel to that line. We need to find something similar for this one, so let's consider 2 points. We have 0, 1/2, and also the point 1, 1. And if we make a subtraction between these 2 points, for example, we have 0 minus 1, which is minus 1, and 1/2 minus 1, which is minus 1/2. This is another vector which goes along the red curve. It is parallel to the red curve. And if we take the dot product between these two vectors, we need to find 0. Okay, so the dot product between these two vectors is given by minus 1 times minus 1, so it's 1. And then we have plus 2 times minus 1/2, so it's minus 2 times 1/2, which is 1. So this is 0. And indeed, these two directions are perpendicular. This is what we can also infer by considering the dot product.